Hi everybody, Mrs. Pesic here. We are looking at section 5.8, which is solving radical equations and inequalities. And really, in this section, we're only going to be solving radical equations. Your vocabulary is radical equation. What is a radical equation?
Pesley, please call extension 1077. Miss Pesley, 1077.
A radical equation is an equation that contains a variable within a radical. So recall that you can solve quadratic equations by taking the square root of both sides. Similarly, radical equations can be solved by raising both sides to some power. So the steps involved in solving a radical equation, the first step is to isolate the radical. Okay, so if we had cubed root of x minus 2, we'd want to get that radical by itself, so we would add 2 to both sides, and we would get cubed root of x equals 2. Second step is to raise both sides of the equation to the power that's equal to the index of the radical. So since this was a cube root radical, that means we need to raise both sides to the third power. All right, and in this case, cubed root of x cubed would just be x, and 2 cubed is 8. So the third step is to simplify and solve. All right, remember that for a square root, the index of the radical is 2. So if you don't see an index here, it's understood to be 2. All right, let's take a look at this example. So we're solving equations containing one radical. Raising each side of an equation to an even power may introduce extraneous solutions. So it's very important that you check your answers, not because you might have done something wrong, but because you may have introduced extraneous solutions. So taking a look at this first one, 5 plus square root of x plus 1 equals 16. We're trying to solve this equation. Our first step is to isolate the radical. So I'm going to subtract 5 from both sides. We get square root of x plus 1 equaling 11. And at this point, we're going to square both sides because the index was understood to be a 2. And we want to raise both sides to that index power. And so the square rooting and the squaring are canceling each other out. So we just are left with x plus 1 equaling 11 squared, which is 121. And at this point, I'm going to subtract 1 from both sides, and I get x is equal to 120. Now let's check our solution. So here's our check. We're going to do 5 plus square root of 120 plus 1. Is that equal to 16? Question mark. You could enter this in your calculator and do it true or see if it says true or false, but I'm just going to do this by hand. It's 5 plus the square root of 121. Is that equal to 16? Well, square root of 121 is 11, and 5 plus 11 is indeed equal to 16. So we like this solution. Let's take a look at our next example. This one says we want to solve 7 times the cube root. Slide this down a little bit, slide this down. We want to solve 7 times the cube root of 5x minus 7 equals 84. Well, the radical is not isolated yet because we have this 7 that's being multiplied by our radical. So we're going to want to get rid of that by dividing both sides by 7. So we divide both sides by 7, and we get cube root of 5x minus 7 equals 7 goes into 84 12 times. All right, and so at this point, we're going to notice what the index is. It's a 3, so we're going to have to raise both sides to that power. So we're going to cube both sides of the equation. Now the cube rooting and the cubing are canceling each other out, so we're left with just 5x minus 7 on the left, and 12 cubed. Let me pull up my calculator. 12 cubed is equal to 1,728. All right, so I get 1,728, and again, I need to solve for x. I will add 7 to both sides, so I get 5x equals 1,735. And then I'm going to divide both sides by 5, and I get x equals, what's 1,735 divided by 5? 1,735 divided by 5. I get 347. All right, so my answer should be 347. Okay, and we can do a check. We're going to plug 347 in. Let me get my original, oopsie, my original equation back up here. All right, here's my original. And so I'm going to do 7 times cube root of 5 times 347 minus 7. That's all underneath the radical. And we're wondering, is that equal to 84? All right. So if I'm typing this in, I want 7 times the cubed root. 7 times, I need to get a cube root. So I'm going to do that by doing Control and the caret button. I'm going to type in 3 for a cubed root. And what do I want under my cube root? 5 times 347 minus 7. 5 times 347 minus 7. And then I'm going to do a little right click to get out of my radical. And I want to know, is that equal to 84? So I set equals by doing the equals button, 84. And it does say true, so it works. So we do like the solution of 347. All right, that brings up your first notes must do, where you are solving 4 plus the square root of x minus 1 equals 5. So please pause the video and go ahead and solve that equation. Okay, moving on. We are now looking at solving equations that contain 2 radicals. All right, well, we can't necessarily isolate the radicals every time, but we can at least try and get them on 2 separate sides of the equation. In this first one, we have a square root radical on the left equals 3 times a square root radical on the right. So in this case, we are going to have to square both sides. All right. So I'm going to square both sides, but what I need you to notice is that the 3 is being squared and the square root is being squared. So you could even rewrite this if you want, like this, right? The 3 has to be squared and the square root of 3x minus 2 is being squared. Okay, on the left, the square rooting here and the squaring are cancel each other out. So I have 7x plus 2. I'm going to write that again here, equals, I know 3 squared is equal to 9, times the quantity, again, the square rooting and the squaring are cancel each other out, 3x minus 2. All right, I can distribute the 9, so I get 27x minus 18 equals 7x plus 2, and then I need a little bit more room to work here. Didn't want that to pop up. Okay, and then finishing this up, we're going to group our like terms together. I'll subtract 7x from both sides, and I'll add 18 to both sides. When I do that, I end up getting 20 on the left equaling 20x on the right. And so I divide both sides by 20, and I get x equals 1. Let's check and see if 1 is a solution for our original equation. Let's bring back our original equation here. And if I plug in 1, I get, our check, I get 7 times 1 plus 2. Is that equal to 3 times the square root of 3 times 1 minus 2? We could enter this in the calculator, but it's probably easier just to do this by hand. So I get 7 times 1 is 7, plus 2 is 9, and square root of 9 is 3. And over here I get 3 times the square root of 3 times 1 is 3 minus 2. So I get 3 times the square root of 1, but the square root of 1 is just 1, so I do get 3 equals 3. So it works, and that means we really do like this solution of x equals 1. All right, let's try this next example. In this case, we have cube root of x plus 6 equals 2 times cube root of x minus 1. Again, the radicals are isolated, at least as far as getting one on one side of the equation and the other on the other side. That's a good start. But here we do have to cube both sides of the equation. So I'm going to cube both sides because we're working with cube roots. But you know that means that the 2 has to be cubed and the cube root radical has to be cubed. So on the left, the cube rooting and the cubing are canceling each other out. So I just am left with x plus 6 on the left equaling 2 cubed times cube root of x minus 1 cubed. So I get x plus 6 equals 2 cubed is 8. and the cube rooting and the cubing are canceling each other out, so I have 8 times the quantity x minus 1. At this point, I'm going to distribute the 8. You know, if I'm going too fast for you, you are using that pause button, right, and rewinding if necessary. So I get 8 times x is 8x minus 8 equaling x plus 6. At this point, we're going to subtract x from both sides and add 8 to both sides, and I end up getting 14 equaling 7x. Let's solve for x by dividing both sides by 7, and I get x equals 2. We need to check to see if 2 is a solution and not an extraneous solution, so let's plug 2 into our original equation. You always need to be checking. So for our check, I'm going to do cube root of 2 plus 6. Is that equal to 2 times the cube root of 2 minus 1? Well, 2 plus 6 is 8, so I get the cube root of 8, which I know is 2, because 2 cubed is 8. And on the right side, I get 2 times the cube root of 2 minus 1 is 1, and the cube root of 1 is 1. So I do get 2 equals 2, which works, which means we like this solution of x equals 2. All right, let's take a look at example 3. It says solving equations with rational exponents. So this time, instead of seeing radicals, we're seeing rational exponents. So remember, to find a power, multiply the exponents. All right, so we're going to get back to this hint in just a minute. But I see that this is being raised to the 1/3 power. You know that's the same as cube root, right? So if that's the same as cube root, we really do need to cube both sides of the equation. All right? Oopsie. So we're going to raise both sides of this equation to the 3rd power. We're not multiplying by 3. We're raising both sides to the 3rd power. But when we raise a power to a power like this, we're really multiplying. And that's what we're seeing here in this little example. If you want to do x plus 12 to the 1/2 raised to the 2nd, that's the same as x plus 12 times 1/2 times 2. And then 1/2 times 2 is just 1, so we just get x plus 12. So let's try that here. I get 5x plus 7 raised to the 1/3, but we're raising that to the 3rd. That means we want 1/3 times 3, and that's going to be equal to 3 to the 3rd, which I know is 27. So at this point, 1/3 times 3 is just 1, so I get 5x plus 7 to the 1st now is equal to 27. I can subtract 7 from both sides, and I get 5x equals 20, divide both sides by 5, and I get x equals 4. All right, let's do a quick check to see if that works. If we plug 4 into the original equation here, I would get 5 times 4 plus 7 in parentheses raised to the 1/3. Is that equal to 3? Again, you could do this on your calculator, but it might be faster to just do it by hand. I get 20 plus 7 to the 1/3, but you know that's the same as saying the cube root, right? So I really get cube root of 27, and is the cube root of 27 equal to 3? Yes, it is, so I get 3 equals 3. So we like this solution of x equals 4. All right, let's try this example. Slide this down, slide this down, slide this down. So if we're trying this example, we're going to raise both sides to the what power? Well, since it's being raised to the 1/2, and 1/2 is the same as square root, that means we want to square both sides. All right? So we're going to raise this side to the 2nd power, and we're going to raise this side to the 2nd power. Keep in mind here, not only is the x being squared on this side, but the 2 is being squared also. 2 squared times x squared. And on the right side, we've got 4x plus 8 to the 1/2 raised to the 2nd. So that's 4x plus 8 raised to the 1/2 times 2, which is just equal to 1. So I get 4x plus 8 on the right, and I get 4x squared on the left. So let's solve this one This one turns out to be a quadratic equation. I like to have my leading coefficient positive, so I'm going to bring everything over to the left side. I'm subtracting 4x from both sides and subtracting 8 from both sides. So I get 4x squared minus 4x minus 8 equals 0. Now I notice that 4 goes into everything here, so we can make our lives a little bit easier if we divide both sides of the equation by 4. So in this case, I get a 1x squared minus 1x minus 2 equals 0. Is this factorable? Well, let's check. The product equals negative 2, and the sum is equal to negative 1. And so the two numbers that would work would be negative 2 and 1. I think that sounds okay. So I'm going to do x squared minus 2x plus 1x minus 2 equals 0. And we're going to factor by grouping. So I can factor out an x, and I'm left with x minus 2. And I factor out a 1, and I'm left with x minus 2. So I end up getting x plus 1 times x minus 2 equals 0. At this point, I'm going to set each of these equal to 0 to solve this equation, and I get x equals negative 1, and I get x equals positive 2. Let's plug those into our original equation and see if they work. So if I plug in negative 1, slide my notes must turn down a little further so I have some room. Sliding down. Okay, so if I'm going to plug in negative 1 into my original equation, I'm going to have, this is my check here, I'm going to have 2 times negative 1. Is that equal to 4 times a negative 1 plus 8 raised to the 1/2 power? Well, on the left, I get negative 2. And on the right, I get negative 4 plus 8 to the 1/2. But I know that that's 4 to the 1/2. And I know 4 to the 1/2 is the same as square root of 4. So is square root of 4 equal to negative 2? No. This square root of 4 is positive 2. So I get negative 2 equals positive 2. That does not work, which means that we don't like x equals negative 1. We're going to cross it off, and we're going to write extraneous. Okay, let's do a check with 2. All right, so I'm going to do 4. Lost my original equation. There it is. So I want 2 times, use this in here. So I want 2 times 2. Is that equal to 4 times 2 plus 8 raised to the 1/2? So we're checking this. 2 times 2 on the left is 4, and then I get 8 plus 8. I'm getting 16 to the 1/2 over here. Well, 16 to the 1/2 is the same as square root of 16, and that is equal to 4. So that one does work. So we like the x equals 2 solution, but not the negative 1 solution. All right, that brings up notes must do number 2, where you are going to solve this equation. X plus 5 to the 1/3 is equal to 3. So go ahead and pause the video so you can solve this notes must do equation. Okay, let's look at one more example here. This one we're solving x square root of x plus 15 equaling x minus 5. This is a very important one because many students get this problem wrong. And here's why. When students try to square both sides like this, they get x plus 15 okay on the left, but then they think the right side is just like x squared minus 25, or maybe x squared plus 25. But that is not correct. So let's talk about why that's not correct. So x minus 5 quantity squared is really x minus 5 times x minus 5. So you're really squaring a binomial, and you end up having to do FOIL. So here we're going to have x squared. Outer term is a minus 5x. Inner term is a minus 5x. And the last term would be a positive 25. So we really end up with x squared minus 10x plus 25 on the left, on the right, and on the left we have x plus 15. So solving this the rest of the way, we're going to subtract x from both sides, subtract 15 from both sides, and we end up getting, let's see, 0 equaling x squared minus 11x plus 10. If we try and do product sum here, the product is the 1 times the 10, which is 10, and the sum is negative 11. So for this one, I think I would go with a negative 1 and a negative 10. They multiply together to give us positive 10 and add up to negative 11. So let's take out this middle term and replace it with a negative 1x and a negative 10x. So I've got x squared minus 1x minus 10x plus 10, and I'm going to factor by grouping. So I get x times x minus 1, and then I'm going to factor out a minus 10, and I'm also going to get x minus 1. And in this case, I end up with x minus 10 times x minus 1. Remember, this is still equal to 0, so I am going to set each of these equal to 0, and I get x equals 10 or x equals 1. Let's check these in our original to see if they work. If we try 10 first in the original, you copy my original, whoops, copy my original here. Okay, so if I'm going to plug in 10, I'm going to get square root of 10 plus 15. Is that equal to 10 minus 5? Well, I get square root of 25 on the left, which is 5, and 10 minus 5 on the right is 5, so that works. That means we like the solution of 10. Let's try plugging in 1. Okay, so if we're trying 1, I'm going to have square root of 1 plus 15. Is that equal to 1 minus 5? Well, on the left, I get square root of 16, which is 4, and on the right, I get negative 4. But 4 is not equal to negative 4, so this does not work, and that means we do not like x equals 1 as a solution. We're going to cross it off, and we're going to write extraneous. So x equals 10 is the only solution. Okay, that concludes our video on section 5.8. Thanks for watching.